Next is we are going to learn a concept called order of growth, right? Order of growth. Remember that as I discussed earlier, for the given problems we are having multiple solutions, right? Out of that, which one is the considered to be the best solutions is based on order of growth efficiency class. Remember, order of growth we are not going to find out for the lesser size of input, because some programs for the lesser size of input it works very well. It will take lesser amount of time, but it's fail when you're going to consider for the larger size of input, right? It will take then more amount of time to perform the task. Maybe you would have studied bubble sort, right? Quick sort, or if you have not learned quick sort, we are going to learn it in these courses, right? So both is having the different time complexity, and that is happen not only algorithm technique, it also depends on input size. Okay, so input size is very important. I'll give you here example, right? So order of growth is also very important parameters, right? And this we are going to discuss under analysis framework. What will happen here when you are talking about analysis framework? Right? So analysis framework is depends on order of growth, measure input size, time complexity, space complexity, so few terminology is very new to you, right? We are going to address it. Analysis framework, when you are going to analyze any algorithms, we are going to analyze based on these points: order of growth, time complexity, space complexity, measuring input size, and then we have output. Measure output. So when you're writing the programs, you'll be thinking about, what is the size of input, right? Then we are talking about what formula you're going to apply, what method you're going to apply to solve the problem. Definitely, it will take a space complexity is called here amount of space is required to run the program in your system. Time complexity, amount of time is required to run the program, right? So these all are very important features, but we are going to stress upon, we are not worried about a smaller size of input, we are really worried about the larger size of input. We are having different efficiency class. That behaves differently based on the input size, that we need to discuss, right? Say we are going to discuss input along with the different efficiency class. Say here it is input size, and here we have a different time complexity, that is a function of time, right? What is that? Say we have a linear n, we have log n base 2, we have n square, we have n cube, we have 2 power n, and we have a n factorial. And one more we are having it is very important efficiency class, that is n log n base 2. So we are going to add that n log n base 2. So this is log n base 2 and this is n log n base 2. So let us discuss this and find out what is real order of growth. Since it is log n base 2, n log n base 2, base is 2. Remember that logarithmic properties. Log 2 base 2 is 1. By default, log has base e. Then we have to go and discuss in the form of log n base e, right? And for that we require calculator. Even many of international books, they used to use log base 10. Even you are going to use base e or base 10, we require calculator for each and every steps, because we don't know that log 2, in the case of log 10, 2 values, right? Log 4 values, log 20 values. For everything, so it depends on the calculator. So what you are supposed to do, go in simplest way. Take value of n in the multiple of power of 2, 2 power I. Go in that form, 2 power I. So if I is 0, you take that 1. So input size is 1. N is 1. So here n is 1. Log 1 base 2. Log 1 base 2. Log 1 base anything is 0. So we are going to write 0. Now n log n, 1 into 0 is 0. N square, n is 1. 1 square is 1. N cube is 1. N 2 power 1 is 2. 1 factorial is 1 factorial is 1. If you have any difficulties, you can use the calculator and check that. Okay, so we can see in these scenarios, n is having higher order of growth than n log n, and it is equal to n square, n cube and n factorial. That is not going to be happen in the real time programs. Let us go 2 power 1, 2. So n is 2, 2. Log 2 base 2, log 2 base 2, log n base n is 1. So log 2 base 2 is 1. N log n base 2. So it is multiple of these two columns. So 2 into 1 is 2. 2 square is 4. 2 cube is 8. 2 power 2 is 4. 2 factorial is 2. By seeing this row, we can see that n cube is having higher order of growth, even though more than 2 power n exponential and n factorial, right? So still we have to increase the input size. We need to increase the input size. As I said you, our program should work for the larger size of input as well. So let us see that 2 square 4, it is 4. Log 4 base 2 is 2. This is multiplication of first two columns, 4 into 2, 8. It is 4 square, 16, 4 cube, 64. 2 power 4 is 16 and 4 factorial is 24. Still we can see that n cube is having higher order growth, right? But here we can see 2 power n and n factorial got the more order of growth than 2 power n. Similarly, in the case of 8, here we get 3 into 8, 24, 8 square, 64, 8 cube, 512, 2 power 8. When you are talking about 2 power 8, it is 256, right? Then here we have 8 factorial. Remember that 8 factorial is very big values. 8 factorial is very big values, because 6 factorial is 120, 7 factorial is 720, 8 factorial is, it is 4950, right? So 8 factorial. Thereafter, a moment you are going to check for n is equal to 16, you will be getting proper order of growth. Now we can see that here only n cube is giving more order of growth than 2 power n. A moment you are going to discuss for 16, it is 16, it is 4, 64. This is 16 square, 256, 16 cube, 256 into 16. This we are getting 2 power 16. It is almost, it is 65536, and 16 factorial is very, very large values, very, very large values. So in that case, you can see here is we got proper order of growth, and these all is called efficiency class. Since it is n, it is called it as a linear. This is logarithmic, right? This is quadratic. This is cubic. This one is exponential, and this is factorial. So these all are basic efficiency class. Now we are going to write down the order. Which is having lesser order among this? Of course, log n base 2. So we are going to write log n base 2 is lesser in complexity than n. Look, n log n and n square. N log n is having lesser order of growth. So we are going to write n log n base 2. Next, n square. Thereafter, n cube. Then 2 power n, then n factorial. Remember, our programs will fall in this complexity. So, suppose based on the given problems, we have more than one method. So, we are going to check that if first algorithm is taking log n base 2 complexity, second algorithm is taking n log n base 2 complexity, we'll go with log n base 2 because it is more effective one. Similarly, say one algorithm is giving you, first algorithm is giving n square, second is giving you n log n, third is giving you n cube. Then we'll go with the second method having time complexity of n log n base 2. So basically order of growth or basic efficiency class will tell you, right, which algorithm to be preferred or considered to be the final choice for the programmer. So this is all about your order of growth. So let us see that what we have discussed. Compare basic efficiency class, compare order of growth, we have done with that. Now let us see, in this we are talking about running time and memory space required. Remember that time complexity is amount of time is required to run the programs. Space complexity is amount of space is required to run the program. Right? For this, we have inbuilt function called clock that is defined under time.h header file. Time.h header file. So we are going to use start time, end time. I'll be discussing again in coming slides how you are going to compute this time complexity, okay, for the given problem scenarios. Very important, worst case, best case, average case efficiency. Best case is when your program's basic operations runs lesser amount of time, is called best case. Average case, when our program's basic operations runs more than best case, lesser than worst case scenarios. It's called average case. Third is worst case, when our program's basic operations executing for longest time, larger amount of time is called worst case scenarios. Say as for example, in your class, there are 10 members sitting in first row, right? And I am going to search from left to right side, left to right. So a person is sitting at the first place and I am going to search that person only. It means what? We require only one comparisons, right? To search that particular person. Person is sitting at the last place. Then we need to go search from the left side, one after one, one by one, and finally we are going to that 10th place, right? It means it's required 10 comparisons. But a person is sitting in the between, right? That will take lesser amount of time compared to worst case and more amount of time compared to best case. Maybe it will take, 4 to 7 comparisons considered to be the average case scenarios. So this is what best case, worst case and average case we are discussing here. Okay. Now very important for your exams as well is use the most appropriate notations among O, omega, theta. I will discuss what is O notations, omega notations, theta notations under asymptotic class. Indicate the time efficiency in a best case, average case, worst case of sequential search. What is the problem here? Sequential search. It means we are supposed to write sequential search program. Then we are going to analyze it. What could be the best case, worst case and average case scenario. As I have given the example of your class, best case is person sitting at very first place whom we are going to search. Person sitting at the last place or not present in this considered to be the worst case. A person sitting in the between is considered to be the average case. So that we are going to analyze with this example. So in this, when you are dealing with sequential search, we are having arrays. We have array. Say we have elements called 5, 20, 3, 7, 18. Right? And index start from 0, 1, 2, 3, 4. Key element, we need to decide key element, say first time we are going to consider key element as a 5. Right? So what are you going to do? I pointer start from 0. If I is less than n, n is what? Number of elements. How many number of elements is there, friend, here? 5. I is 0. Is 0 is less than 5? Yes. A of I, A of 0. A of 0 is not equal to k. A of 0 is 5 is not equal to 5? No, it is wrong. 5 is equal to 5. So this statement will terminate. We are not going to increase the I values. We are coming here. I is less than n. Yes. Value of I is 0. Is 0 is less than 5? Is 0 is less than 5? Yes. Then return I. Return I means what? 0. It means element is found. Key element found in one comparisons. One comparisons. So remember that comparisons is here basic operations. Now, how are you going to define this? Best case scenarios, we are going to define with omega notations. So we are writing time complexity is omega of 1. Why 1? Because it took only one comparisons. Let us say when element is either key element is 18 or any other values which is not present in this. Say it is 15. Both the cases, what is going to be the time complexity? Again, you will start the journey from the beginning. I is equal to 0. Is 0 is less than 5? Yes. A of I, A of 0. Is A of 5? 5 is equal to 18? No. In that case, this is true. This is true. Both are true. Hence, AND operator is 1. 1 and 1 is 1. So, I is equal to I plus 1. Now, I came to first position. Again, is 1 is less than 5? Yes. A of 1 is 20. Is 20 is equal to 18? 20 is not equal to 18. So, again, this is true. I is equal to I plus 1. I increases. I came to 2. A of 2 is 3. Is 3 is equal to 18? No. Condition is true. 3 is less than 5 and 3 is not equal to 18. So, I increases. I is equal to I plus 1. 3. A of 3 is 7. Right? So, is 3 is lesser than 5? Yes. A of 3, that is 7. Is 7 not equal to 18? Yes, it is true. So, both are true. Hence, I is equal to I plus 1. 3 increases to 4. And A of 4 is 18. Now, we are going to compare. Is 18 is equal to 18? We are going to write 18 not equal to 18? No, false. So, if this is false and this side is 4 is less than 5, it is true, but 1 is false. Hence, this AND operator will give false. It will come out from this while loop and we are going to check the condition here. New condition is 4 is less than 5. Yes. Then return I. It means what? Element is present at, index 4. A of 4 is 18. How many comparisons were required, friend? 1 comparisons, 2 comparisons, 3 comparisons, 4 comparisons, 5 comparisons. It means number of element was 5, 5 comparisons. Number of element is n comparisons. So in that case, worst case scenarios when element found at last positions or not present in given list. Best case when element present at first position. Remember, position is different, index is different. Position we will call it as it is first position, second position, third position, fourth positions. Natural number. Index, either you can start with a 0 or 1, depends on the programmer. Now we are going to deal how to find average case scenarios. Average case complexity. Average case complexity means what? Maybe number of comparisons will be more than 1, lesser than n. But remember, average case scenario is difficult to find. It will take more time, more knowledge, more mathematical operations. So let us see that. How to discuss average case of sequential search. Sequential search. In this case, we are going to consider probabilities, and you all are aware of probabilities. Okay, so we are going to consider probability of successful search is what? Probability of successful search is P. Then we are going to call it probability of unsuccessful search, because either element is found or not found. Unsuccessful search is, remember that maximum probability is 1, range of probability is 0 to 1. For successful search is a P, then unsuccessful search must be 1 minus P, because sum of this is going to be 1. So that is the successful search, unsuccessful search. Now, when we are talking about T average, it means element can be found at the first positions or second positions or third or nth positions. So this T average is going to be successful event and unsuccessful event. We are going to analyze both the probabilities. So if this is a probability, successful search is P for all n elements, then what will be the unit element probability? Unit element probability is going to be P divided by n. So we are going to write, if first element is there, along with that probabilities you are talking about. Okay. If second element is there, we are going to write 2 into P divided by n. Similarly, third place element is found, 3 into P divided by n. Similarly, we are going to call it as a, if element is found at the nth positions, n into P divided by n. Don't simplify it, n cross n is cancel and finally is P. Don't cross it, don't cancel it, leave as it is. Okay, 1 into, when element is present at the first position, 1 into P divided by n, 2 into P divided by n, 3 into P divided by n, n into P divided by n. Plus, remember friend, this is for successful search. What will be the unsuccessful search? How many comparisons we have done it? N comparisons. So it is going to be n into, and what is the probability of unsuccessful search? 1 minus P. So we are going to write 1 minus P. Now you are going to simplify this. Once you are going to simplify, what is common factor here? P divided by n. And what is the value? 1 plus 2 plus 3 plus 4 up to n. This side we have n into 1 minus p. Can we simplify this? This is the sum of n terms, 1 plus 2 plus 3 plus 4 up to n, sum of n terms, and we know that sum of n term formula is, sum of n natural number is n into n plus 1 divided by 2. So you can go for that. P divided by n, right, into n plus 1 divided by 2, right? And right hand side parameters we have n into 1 minus p, right? So this part we have solved it and we wrote here. This n and this n got cancelled. In that case, we are getting p into n plus 1 divided by 2 plus n into 1 minus p. N into 1 minus p. This is the t average of sequential search. Now, what will happen when you are talking about the worst case, average case and best case? What will happen when element is found? Element is found means probability is 1. If element is found, if p is equal to 1, if p is equal to 1 means element is found, p is equal to 1, you put it here. What you are getting? 1 into n plus 1 divided by 2. So we are getting t average is equal to p is 1, so n plus 1 divided by 2. When p is 0, it means what? Element is not found. If element is not found, p is 0. If p is 0 means left hand parameter is 0. I will go in right hand side parameter. N into 1 minus 0. N into 1 minus 0 is, n into 1 is n. So look here. First case when p is 0, second parameter will be 1 minus 1 becomes 0. So second parameter is 0. Only we are getting n plus 1 divided by 2. So this is going to be considered as a average case. Average case time complexity. T average is n when probability is 0. Remember that we have already discussed in the previous concept. If element is present at the last positions or element is not found, in both the cases we are going to do the n comparisons. So here is, if element is p 0 means what? Probability is 0. Probability of successful search is 0. It means what? Element is not found. Hence we are getting n. Okay, so this is all about time complexity for sequential search. Fine. So let us conclude now. Here we have learned basic algorithm concept, introductions, properties of algorithms, then analysis framework. We have discussed about order of growth, basic efficiency class, and best case, average case, worst case of sequential search. Along with that, we have discussed example of GCD, how to write algorithms, how to analyze the algorithms with simple examples as well. And this will help you to think of algorithms in better way. Remember friends, be focus on 5 properties of algorithms, okay, and flow of algorithms to write down the program.